Yeah, we can.
Awesome. Great. Hey,
How you
hey,
doing?
Sergey.
Hey, how are you?
Good, man.
Good. How was your weekend? Did you get any time off, or was it all coding?
Oh yeah, I definitely did. I definitely did get some time off. Have a number of projects that we're working on around the house, so I got some time off the keyboard and got some time behind a power drill.
Awesome, awesome. Sounds good. Maybe we can just get started. For those of you that are joining, hey everyone, I'm Sergey. I'm working on the Axelar network. And yeah, super excited today for this conversation with Zach. And he's working on a lot of things, everything from Sommelier to Cosmos to Strangelove. So yeah, what do you want to give a quick intro on yourself and maybe some of the things you're working on, and we can take it from there.
Yeah, for sure, absolutely. See a number of folks in the audience. Hey, Bo. Um, but yeah, so my name's Jack Zampolin. I've been working on Cosmos since 2018. I've worked a lot on the sort of developer user experience for the Cosmos SDK as well as IBC. And as a part of that, I've ended up kind of working on a lot of different things in the ecosystem. Not only the kind of core software, but also building a network with Zaki Munyon called Sommelier. And I've also ended up advising projects like Juno, um, and working really closely with the Osmosis team to help ship features there. So I'm sort of like broadly active throughout the entire Cosmos ecosystem.
Awesome. I guess curious just to step back. Maybe you want to tell how did you get started, right? How did you get started in the Cosmos ecosystem? How did you get started in the blockchain? Like, what brought you in here?
Yeah, that's a great question. So uh, I'll go all the way back to 2013 when I was a professional chef at the time, and I bought my first Bitcoin during that run up and ended up selling it. But what it did leave me with is a fascination with this space and helped push me towards learning how to code. So I started coding soon after that, just sort of in my free time. And then I did a boot camp in San Francisco back in early 2015. And from there, I started working at a database company called InfluxDB. Um, Fast forward to 2017, my roommate has quit his job in traditional tech to work at a company called Blockstack. And I am spending more and more of my time hacking on various crypto projects. He invited me over there to help them do developer evangelism. So that was my first job in crypto during the 2017 cycle. I started that job in sort of spring of 2017. It was there for about a year. Helped them raise their round and help them with the developer adoption on their platform. And they kind of decided to go a different direction and focus on the stacks-based smart contracts, which is what they're working on now. But the sort of developer platform that I had been developing was kind of gone. So I was looking for a new job in early 2018 and sort of took a broad look at the blockchain ecosystem. And I said, what are all of these different visions of the future that Ethereum and Polkadot and you know a number of other different projects have for the future of blockchain? And for a number of reasons, I ended up choosing Cosmos because it sort of best encapsulated what I believed would be a great future for blockchain, and for adoption. And yeah, I've been kind of working on it since then.
And I guess like, what are some of the key messaging or key technical pieces that I guess attracted you to the Cosmos? Like, what resonated well with you at that time?
I've always had concerns around the energy usage of proof of work. Um, you know, Human caused climate change is a massive society wide thing that we need to face. And figuring out more efficient ways to get consensus than smashing a bunch of computers together, basically, uh, seems to be good in a wide variety of ways. So the sort of core innovation of proof of stake is something that I'm a huge fan of. It also looks a lot like the distributed systems that run in Facebook and Apple and Google and a lot of the huge institutions that uh, maintain large computer installations, but a better and more secure version of that. So that's kind of what drew me to proof of stake. And then the vision of IBC, where there's no individual system that is sort of lording over all of the other systems, that they all sort of interoperate on a peer-to-peer basis, looks to me a lot like the original vision of the internet, the sort of Web 1 that we are all nostalgic for. And it's something that I want to help build, and that's kind of why I've joined Cosmos and spent the last now 5 years of my life on this.
Yep, awesome. Um, and I guess, yeah, shall we talk a little bit about interoperability and kind of IBC and
Oh yeah,
kind of how it connects everything? Let's maybe try to take a step back, right? And I guess one thing that I think people don't talk a lot about, but I think is quite important, is just to talk about properties that interoperability should provide, right? You mentioned like peer-to-peer connectivity as one of the kind of a properties that IBC has. There's a lot of things we can talk about, security, right? What types of messages can be passed, kind of routing, kind of translation, things like that. So why don't we start with security, right? I guess I'm curious from your perspective, right, and kind of how you think about security in general. How should we even define security, right? Good or bad security for an interoperability protocol, let's say, to begin with.
yeah. I think that that's a broad and expansive topic. So let me attempt to touch this. So I think that when you're thinking about security, one way to think about it is sort of threat modeling, like what are the threats that we're looking to protect against? And I think that originally Bitcoin and broadly crypto in general is looking to protect against sort of overweening government influence, um, or the ability of individual actors to sort of shut down the whole network, or even small groups of actors acting in concert to shut down the whole network. And if we're looking at security from that perspective, I think IBC offers some kind of unique security guarantees there, because even if one of the proof of stake networks that makes up the broader IBC network is compromised, there's all of these other ones. Systems like Polkadot or other ones that have sort of one chain that's mediating the communications between other chains takes on the security properties of the chain that does the mediation. Whereas IBC kind of has this heterogeneous group of chains that each have their own security properties. Now, that comes with its own set of issues, but it also solves a number of other security problems. So, yeah, that's a little rambling, Sergey. Do you want to help clarify that a little bit, maybe?
Yeah, I guess let's talk a little bit about this kind of just the connectivity topologies, right? That could happen, and I think it's a quite an interesting topic. So, you brought up, let's say, peer-to-peer connectivity, right? And IBC is kind of a pretty good with that. And then you have kind of a hub and spoke connectivity model, right? Where there's a kind of a hub connected to various spokes and kind of a passing messages, let's say, relaying across them. Even in an IBC world, right, where suppose we're in a world with hundreds or thousands of different chains, right? We, I guess, can't really assume that every chain is going to be directly interconnected with every other chain, right? Like that would require you know n squared, right? An order of n squared connections, requires all the management, like relaying between them and so on and so forth, right? So you're probably still going to naturally be um, in a position where some of the chains are kind of routing or delivering information across other chains and potentially taking the security assumption that all the chains along the path that you're sending, let's say, like your message from a source to a destination, are actually secure in this process, right? So you will be sort of relying on some transmitters, and I think you actually did some work. Correct me if I'm wrong, on like routing for the IBC hub, right, where some of this kind of becomes possible. So is that correct?
Yeah, definitely. I've been kind of the largest proponent of that in the Cosmos ecosystem, and probably done the most work on it. Um, right now, when the IBC network is small, you're right, that N squared is very manageable, but especially as it grows, and we're seeing it grow very, very quickly, we are going to need to start having some sort of routing to help manage the complexity here from an operations point of view. And we're sort of starting to reach the edge of where it's possible to manage that without routing. So
Yeah.
in the last Cosmos Hub upgrade, I pushed a change that enabled you to route tokens through the hub. Now, the token routing thing, and you've, Sergey, done more work on this than a lot of other people. The token routing thing comes with its own particular set of concerns and problems. But I think in the future, we're going to move to this world where we're not necessarily routing tokens, we're more routing smart contract calls or data. And that comes with easier, that comes with less problems, I think. So I think that in order for routing to be really fully fleshed out, we're going to need a larger network, and B, a change in the type of data that's traveling over that network, from concrete representations of value being the way that we transmit data between these networks to, you know, smart contract calls and other sort of like very data based intercommunication. But yeah, I'm really excited for that world, and doing a lot of work to help bring that about, whether it's IBC queries, the ability for one chain on one Cosmos chain to query data from another Cosmos chain, almost like a generic oracle for any data that exists in the Cosmos, as well as productionizing and bringing to market interchain accounts, which is the ability to do sort of these cross-chain function calls in Cosmos.
Yeah, and I think one of the differences between, let's say, like the intranet, right, and the blockchain is that whenever you're talking about peer-to-peer routing on the intranet, um, it's okay to be peer-to-peer and take as many hops as possible, because you're not actually assuming any type of trust properties in the networks, right, or any security from the networks. You're only there to guarantee delivery of messages, right? So, like as an example, you go from one website to a backend server, your packet will probably go from 8 to 20 hops or 8 to 20 different networks along the way, and it's fine because none of these networks are actually supposed to guarantee any security, right? You're only there to guarantee delivery, and then you have protocols built on top of it, like HTTPS, right? SSH, that are application layer protocols that are there to guarantee security, right? And I think, to me, I think one of the big differences between the blockchain model and the intranet model is that, if we were just to directly apply this analogy to the blockchain space, and now imagine my packet goes through like 7 or 8 other networks or 20 other networks as I'm transmitting it. No matter what, like the blockchain network is supposed to provide trust and authenticity and verifiability information, right? So that you can, link it back to the value or general message passing calls or whatever that is. And I think there, the security assumptions that you're going to have to be taken will start being amplified, right? So I guess, like, I do think in the blockchain world, minimizing the number of hops and minimizing the number of connections actually comes with pretty significant benefits, where you can reduce the attack surface, right, and reduce the layer of assumptions that you make along the way as you transfer the packets. What are your thoughts on this?
Yeah, I mean, Sergey, I completely agree with this, and I think that this is where a network like Axelar really has a strong market niche. You know, the the Cosmos chain to Cosmos chain, and sort of like once you're in this IBC world, being able to send between chains is very easy. But bringing in some of these other chains that you guys are, the various EVM related chains, the various other proof of work chains, requires a specifically designed zone to do that. And you guys really are, I think, the best effort right now to play that role of bringing assets that are sort of hard to build IBC directly to into the Cosmos ecosystem. Axelar is doing a great job at that.
Thanks. And yeah, I guess let's talk about like other pieces of infrastructure, right, to make interoperability happen. And I think a part of it is relayers, right? And I think you've also done a lot of work on relayers for IBC and Cosmos. Um, I guess curious, if you can summarize for the listeners, what is the current state, I guess, of let's say IBC relayers, right? What are they doing, and then maybe we can talk about some economic models behind them.
Yeah, for sure. Relayers are the little machine elves behind the scenes making everything happen. Uh, in the
Yep.
in a kind of flip way, but in reality, like if you're looking at these systems, all of the pieces that we're talking about, these interoperability pieces that we're talking about so far, are all the on-chain pieces of this. Now, this is like kind of technical, but a blockchain cannot make an HTTP request to another blockchain. It could properly format a transaction that will be accepted on another blockchain, but it can't actually go submit that transaction to another blockchain. There's some actor that needs to do that. And that is kind of fundamentally what a relayer is at the end of the day. It's the piece of the system that helps complete a lot of these sort of automated transactions and do them repeatedly. Now, what is the current state of this? Right now in IBC, relayers are unincentivized, but practically what's happening is that each project in the IBC space is sort of paying a small set of people to do this relaying. So this looks like a lot of other infrastructure providers where you're providing quality of service, and you've got an on-call rotation where you're making sure that the quality of service is maintained on the channel. That's all well and good, but another thing that relayers are doing is also working really hard on individual node performance, fixing issues with different pieces of the system, and working really hard to push forward the scalability of IBC. And relayers sit in this kind of unique position where if we think of the different layers of the Cosmos stack, there's the proof of stake layer down at the bottom with Tendermint. There's the application layer with the Cosmos SDK. There's this on-chain IBC code. And then relayers kind of rely on and work with every different piece of that stack. So we're running into issues often before users are, and helping to fix those and push forward the user experience for all of these chains.
Yeah, and I think like if I actually had to make another comparison here, I think the proof of stake blockchain ecosystem is possible because of the validators in some sense, right? And some of the service and the work that they've been providing by running nodes, like participating in the test nets, right? Like helping hundreds of projects bootstrap at this point. And I think the relayers is probably going to be one of the next critical like infrastructure pieces that these validators will be uniquely positioned to address for the market, right? Because like you said, they in some sense they already have experience running validator nodes or nodes of different blockchains, and it is kind of an infrastructure piece that has the same, I guess, demands for the quality of service, right? With high availability, high uptime, quick responsiveness, and so on and so forth. And I think just a huge, I guess, thank you, right, to all of the validators and also folks that have been running relayers for the Cosmos ecosystem, for other ecosystems, because I think it's a hugely important piece of infrastructure.
Definitely.
What do you think is going to be economic model, right, behind the relayers down the line? And I guess just to kind of expand it, right, relayers are not specific, right, to IBC. Like we at Axelar have relayers that connect IBC and EVM chains, right, between Axelar network and other EVM chains. Similar types of functionality, that needs to be provided. You do have, I guess, a lower guarantees in terms of number of people you need to run these things on average, right? I think we talked about it last week. So maybe a couple is usually enough because you need at least one delivery of the message. You don't need kind of decentralization. on the relay layer because that's achieved by the underlying protocols. But yeah, kind of going back to the question, how do you think relayers should be incentivized? Like, what can we do to continue growing that ecosystem?
Yeah, I think that there's a huge amount of work that needs to be done to make it easier. I think users can end up relaying their own packets via the browser in some kind of end state. But I think that there's always going to be this sort of role for these server side relayers. Now, there's been some work on a relayer incentivization proposal. Basically, each packet that gets transferred via IBC would have a wrapper on it that includes some fees, and those would be sent to the relayer. I think that's part of the answer. And then another part of the answer is users relaying their own packets, more ease of use for this relayer software to make it easier to set up. If you could go to a website and say, hey, I've got this new chain, I need a relayer on this chain. Here's a button I can click that gives me relayers on that chain, and I can, pay their costs. These are all different things that are being developed right now, and I think that some combination of them will end up ensuring quality of service across the interchain. Yeah, I guess relayer incentivization is not necessarily, there's not one answer to this problem. It's an extremely complex problem. And I think fees within blockchains generally are probably one of the hardest and most open design pieces for blockchains in general. But I think we get at this from a variety of angles, both making it easier as well as adding direct incentives.
Yeah, but I guess do you imagine a world where users gonna relay their own transactions? I guess like one challenge with that, especially if you're talking about, you know, not a direct connection, but like a multi-hop, right? Relaying, then user potentially would need to have tokens on different chains, right?
I think multi-hop makes the users relaying their own packets easier because let's say they're routing through the Cosmos hub. They could use the Gravity DEX to automatically trade into the fee tokens for the various chains that they are interacting with, and to leave them on exactly where they want, having paid fees along the way without the user having to like make any direct interventions in that. So that's one way to go. But yeah, like as you mentioned, that is kind of the big sticking point to users relaying their own packets. And there's a number of things that are kind of in flight to enable this. One is the ability to pay fees in other denominations other than the sort of like native chain token.
Yeah.
That's sort of natively within Cosmos right now, but we're adding some code to make that easier. Things like consensus fees. There's a lot of work happening on that. And this combination of like having multiple fee currencies and consensus fees, plus the ability to trade into assets along your route, plus an advance in the JavaScript relaying software. I think those three things combined in 6 to 12 months will bring us to a place where users could realistically relay their own token transfers. Now, if we're talking about some of these data packets, there's kind of a different model there. And I think that will be handled differently.
Yeah, I guess another, layer in between the users, right, and just the network relayers is like application layer relayers, right? Which, I think like we thought a lot about kind of an Axelar where maybe, for some applications you have like you can set up your own relayer and then you can cover all the fees for your users, right? So imagine like you're talking between two smart contracts or two Cosmos chains, you know what the calls are, you know what types of messages will be routed, and like you cover the fees for your users, effectively providing this kind of quality of service.
I mean, this is why I advocated that we drop fees in IBC for the release, is I figured this would be the primary model, and like lo and behold, it has turned out to be the case. We spent, I think, 3 weeks bike shedding fees in IBC. And the design that we came up with required an oracle, required a stable coin, and we were converting all the fees into dollars. And it was just incredibly complex, would have added a year of engineering effort to shipping IBC. So, this argument that the applications, and if we're talking about application-specific blockchains, the applications would cover this for their users. That's great.
Yeah. Let's see. Do you want to talk a little bit about Sommelier and some of the work you guys are doing? Because I think you're doing a
Yeah,
lot of interesting things there as well, and including message passing, right? Do you want to give a quick overview?
yeah, for sure. So, when we're talking about these data-specific IBC and interoperability applications, like that's kind of what we're working on at Sommelier. So the core idea behind the Sommelier chain is that it is a blockchain that manages smart contracts and financial products on other blockchains. And to do this, we have our own sort of custom Ethereum to Cosmos bridge that we've been working on for a while. It's a fork of the Gravity bridge that the Sommelier team has been working on the Gravity bridge since the beginning, and we've been deeply involved with that project. So I have a lot of context there. But the specific fork of the Gravity bridge that we have has been developed to be able to format a Ethereum transaction over on the Cosmos side and then send that over to the Ethereum side to do automatic rebalancing of Uniswap v3 pools. Was kind of the first use case. We pivoted away from that, and the first seller that we're going to be launching is an automatically rebalancing Aave pool, where you're moved into the most profitable stable coin on Aave automatically as that sort of changes dynamically. But this machinery can be used to manage contracts on any EVM chain. And we're going to be expanding that network and adding more EVM chains to manage. But this sort of general architecture can also be used on Cosmos to, say, manage liquidity within osmosis pools or positions over on Anchor protocol on Terra. And we're also working on the pieces to enable this sort of data and smart contract call based system to be adopted all across the interchain.
Yeah, so I'm actually quite interested. So if we kind of dive a little bit deeper, where's the message, I guess, construction happen? So as a user, you send like some message to the Sommelier chain, and then you have on-chain logic that takes that message, creates like, let's say, like an EVM compatible message, and then you want to relay to the EVM chain and kind of execute there. Is that the correct flow?
Well, the Sommelier, that kind of the correct flow, except these EVM calls are not user initiated. They are initiated from within the state machine. So the state machine over on Sommelier has a list of Ethereum contracts that it is managing, and the validators periodically vote to send smart contract calls over to those managed contracts. So the smart contract calls all originate from within the state machine on the Sommelier side.
Got it. Okay, yeah. So that's super interesting, right? So I guess what you're saying is that, traditionally as a user, I have to, if I want to rebalance, like I go and execute these transactions, right? And you're saying, okay, we have now sort of an application specific chain that sort of automates this flow for you, and you can, you can walk away, right? And don't have to worry about it if something needs to be like rebalanced or moved from one pool to another.
Exactly. And, all of the efforts to do this so far have all basically relied on custodial services, where some smart contract or off-chain process is given ownership over the funds within a smart contract. And I think you can very easily see how that is sort of counter to this decentralization narrative that we have as a community, and counter to this sort of like autonomous part of DAOs, is that at the end of the day, anything that's happening in an automated fashion, we're delegating responsibility to an individual key running on a cloud server somewhere. And those kind of security trade-offs, and like back to the conversation earlier about security trade-offs, those kind of security trade-offs are not great. Like that, as an Ethereum user and as somebody who uses some of these smart contract protocols, I'm not a huge fan of that architecture. It's one of the main reasons why we've built Sommelier, is to take that out of this sort of custodial nature, which has not only security implications but also regulatory and legal implications that are not great. And as a U.S. citizen, and I like I am probably more exposed to this than some others that don't live in the U.S. Um, you know, having that behind a decentralized set of validators that is making those decisions in a transparent way is better from all of those perspectives. And I think a model that we're going to end up moving towards as an industry.
Yeah, makes sense. And I guess because you're constructing like general messages, so let's say like in the coming months, we're going to be adding like general message passing like through the Axelar stack. So then you can technically also route your message as an IBC message to like an Axelar network from which it gets like delivered and executed on EVM chains as well, right? Because it's just a general payload.
Exactly.
Yeah, makes sense. Awesome. Sounds good. Well, I think this is super interesting. Anything else you want to talk about?
I mean, I'm excited to work more with you guys. I think we're working together right now to set up some IBC channels with Juno. Um, I know that you guys have a lot of exciting things going on within the Cosmos ecosystem, and as you kind of continue to turn on more pieces of functionality of Axelar, I think you guys are going to play an increasingly large role within the ecosystem. So really excited to work more closely with you. I guess any questions I have or comments. I see Joe Bowman here in the chat. When we were talking about things like IBC queries and these ability to do more complex forms of interoperability, Joe and the Quicksilver team are working on a liquid staking protocol where there's an entire Cosmos blockchain that's sort of managing the distribution of stake between a number of different validators. These are the kinds of things that we're going to see increasingly moving forward. And the work that you guys are doing, that I'm doing, is all kind of like helping to bring that into reality. Really exciting. And when I started, earlier in this conversation, we were talking about sort of like how I got started in crypto. When I started at Cosmos, people would talk about IBC, and I was like, yeah, sure. Like maybe when we ship the platform, like I'll believe this IBC thing. And watching a lot of these things that we talked about sort of theoretically way before this stuff was even live sort of happened, the competition between various different peg zones, the more advanced forms of interoperability, really, really exciting and really awesome to see. I'm excited that we're here now.
Yeah, for sure. I mean, likewise, I think super excited to kind of see everything you guys are working on, and I think you kind of helped the whole ecosystem like across the stack, from infrastructure all the way, to protocol application layer development. Um, I still think it's quite early, right, for everybody. I think we're still kind of at a place where we're setting up, core connectivity pipes, right, and core uh, basic, relaying and message passing. I think, routing. I think it's still like in an infancy, right, and I think all of that is going to continue being built over the years with some of the work you guys are doing, us at Axelar. We need like better application layer protocols, right, to make it easier for the applications and the users to interact with the cross-chain ecosystem. So likewise, super excited to continue working with you guys and the rest of the ecosystem. And yeah, thanks so much.